In our research, the theme of the work is to try to record electrical signals in 3 dimensions. We are trying to understand some basic electrophysiology phenomenon using nanoscience or using nanosensors. Industry in the future can use these ideas to scan for new drugs. We can use these ideas to study disease. So we are trying to come up with different approaches that will enable us to record electrical signals from, let's say, cardiomyocytes or neurons. You have an organelle or microorgan that is 200 microns in size, so it's just twice the diameter of human hair, give or take. And it has around 1,000 cells, and these cells are electrically active. There are no current techniques that will enable us to record signals from this organ or microorgan in 3 dimensions. So this is where nanoscience comes into play, because now we know how to create these nanosensors, and we know how to potentially fuse them with the tissue. So we essentially try now to bring these 2 worlds together. Essentially, this chip holds several microtissues composed of cardiomyocytes and will enable us to continuously monitor their electrical activity in 3 dimensions. So we'll be able to look at it. So it won't be just a snapshot of what's going on within the tissue at a certain time, but we can potentially do it continuously. So we are developing these platforms that will enable us to image through the sensing unit and come up with different approaches to record, again, signals from cells. A very unique property of graphene is that it is transparent, as you can see. We came up with a different approach where the graphene is not just grown in 3-dimensional catalyst, but is growing literally in 3D. So instead of having a flake or a film of graphene that is attached to a surface, the graphene is growing off the surface. Essentially, we came up with a new way to create truly 3-dimensional graphene. The project that we will work on in the next few years will be involved with essentially fusing nanoelectronics with brain organoids. Essentially, it will be fusing human-like tissue with nanosensors. This will give us, in essence, knowledge about how to create a better interface between sensors and neuronal tissue. I truly think that the future relies on nano-bioelectronics and advancements in my lab, in other labs around the globe, with regards to bioelectronics and nano-bioelectronics, will have an impact.